In this lesson, we're going to be adding and subtracting rational expressions, and this is going to be the second part. In the first part, we had done 5 problems, and we were talking about getting common denominators and figuring out what was missing, and so we're just going to continue that. So we've done 5 already, so we're going to start with number 6. So number 6 is going to look like this. 3x over x minus 5 plus 3x minus 1 over 3x squared minus 16x plus 5. So a little bit more complicated denominator on this one, but the concept is still exactly the same. We want to factor out our denominators, see what they share, see what they don't have, and then fill in the gaps basically. So for this quadratic, we need to factor it. So the only way I can break up 3x squared is with a 3x and an x. And I know that the outside terms and the inside terms need to combine and make 16. This tells me my signs are going to be the same, and this tells me they're both going to be negatives. So my only choices to break one up are to have a 1 and a 5 or a 5 and a 1. But I want the 5 to be across from the 3 so I can get a 15, which is close to 16. And then if I put the 1 in here, that'll be a negative 1, negative 15, which gives us our negative 16. Great. So now I can look at what do I have, what do I not have with each of the fractions, each of the denominators. They each have an x minus 1. So, but they don't each have a 3x minus 1. So this piece needs 3x minus 1. And we'll have to multiply that to, we'll have to multiply that to the numerator and the denominator. So 3x minus 1 is being multiplied to both. So that is going to get us a distribution needs to happen, so we'll distribute the 3 into both of those. So that's going to be a 9x squared minus 3x with our common denominator of 3x minus 1, x minus 5, and then plus, we didn't have to do anything to that one. It already had, it had one of the pieces, but it doesn't miss the other one, so we just have a 3x minus 1. I don't need that. I have a 3x minus 1 over the 3x minus 1 and x minus 5. All right, so we have our common denominators. That means we can put our numerators together, and if we do that, that is going to get us a common denominator of 3x minus 1, x minus 5. We add our like terms together, that'll be a 9x squared. Our negative 3x and positive 3x cancel, and so we just have a minus 1. So we're going to look to try and factor this and see if anything reduces. This is a difference of squares, so this will factor into 3x minus 1, 3x plus 1 over our common denominator of 3x minus 1 and x plus 5, and we have common factors that will cancel each other away. 3x minus 1 cancels the 3x minus 1, and we have left a 3x plus 1 over x minus 5. All right, and that is reduced as far as we can go. Now there was one little potential shortcut at the very beginning. The very beginning we did have these common factors, so this fraction could have reduced, and not only could it have reduced, let me show you what that would look like, is if that would have reduced, we would have had a 3x over x minus 5 plus the 3x minus 1s would have canceled, so you would have had a 1 over x minus 5, which would have already had a common denominator, and our common denominator is x minus 5, and if we put our numerators together, we would have had a 3x plus 1, which matches the same thing that we got. So sometimes there's a recognition that we might have an actual shorter situation happening. So if you recognize it, great, and then if you even have common denominators, even better, it allows you to just put your stuff back together. All right, so let's do another one. So number 7, we have 4c over ab and plus 3b over ac minus 2a over bc. We're looking for common denominators, try to put everything together, and this one has an a and a b, but it doesn't have a c, so we need a c multiplied to this. This one has an a and a c, but it doesn't have a b, multiply it by b. This one has a b and a c, but it doesn't have the a, so we'll multiply it by a. Alright, so if we do that, we're going to get a 4c squared over abc plus 3b squared over abc plus minus 2a squared over abc. Alright, if we combine all that together, our common denominator is abc, and our numerator becomes 4c squared plus 3b squared minus 2a squared. Now we would look to try to see if we can find a common factor in our numerator. They all have different variables, and there isn't a number that divides out of every single piece, so that is as reduced as we can go. Alright, let's do another one. So if we have 1 over x minus 3 minus 2 over x plus 3 plus x over x squared minus 9. And if we are looking to put this fraction together, we need our common denominator. First thing I'm going to look to do is take anything that I can in the denominator and factor it. This is a difference of squares, so it's x plus 3, x minus 3. And now looking at that, we have an x plus 3 and an x minus 3. This one has an x plus 3, it needs the x minus 3. This one has an x minus 3, it needs the x plus 3. And this one doesn't need anything, it already has them. So let's distribute. But another thing that I'm also going to do is, I don't like this subtraction, because some people will make a mistake because they'll distribute the 2 in and not realize that they're subtracting both of those terms. So I will also take that subtraction sign and I will apply it to the 2. So now it's a little more obvious to me that I'm distributing a negative 2 to everything. So that's going to give me an x plus 3 over our common denominator of x minus 3, x plus 3, and then plus, I have a negative 2 distributed to both, so a negative 2x plus 6 over our common factors, x minus 3, x plus 3, plus nothing distributed to that, so just x over our common denominator, x minus 3, x plus 3. And so now let's put everything together that we can. So we have an x plus a negative 2x plus an x. Those actually will cancel each other away, and we're just left with the 3 and the 6 making 9 over x minus 3, x plus 3. Alright, now let's put together one more. So if we have x over x squared minus 16 minus 6 over x squared plus 5x plus 4. Alright, so we need to find factors, see what they have in common. I really don't like the subtraction of 6, so I'm going to change that right away. I'm going to add and make that a negative 6, so if I have to multiply it, I'll distribute a negative through. This factors, it's a difference of squares, so x plus 4, x minus 4. This factors into what multiplies to 4 that adds to 5, x plus 4, x plus 1. And what do we have? What do we not have? This one doesn't have the x plus 1, so I'll multiply x plus 1, top and bottom. This one doesn't have the x minus 4. All right, so let's distribute. See what we got. So x times x is x squared plus x over, we're going to have 3 terms for our denominator. So we're going to have an x plus 4, x minus 4, x plus 1, all over negative 6 distributed, so that's a negative 6x plus 24 when you distribute a negative 6 to a negative 4 with our common factors x plus 4, x minus 4, x plus 1. And let's put together what we can. So we have x squared and then minus 5x plus 24, all divided by those 3 factors, x plus 4, x minus 4, x plus 1. And we're going to try and factor this, see if there's anything that multiplies to 24 that adds to negative 5. Now, I would say 8 and 3, but this is telling us that our signs have to be the same, which really means that they need to differ by 5. And there's nothing that we're going to be able to multiply that will differ by 5 that multiplies to 24. So the quadratic's not factorable, which means none of these factors are going to match anything from here, and that is as good as we can do it. All right, and that was adding and subtracting rational expressions, a little bit more challenging, part 2.